take a look at public opinion, public awareness, and also how the public might respond to the issue of ocean acidification by the consultative group on biological diversity, and in specific, a group of marine funders who are very interested in all types of ocean conservation initiatives, wanting to take a look at what should we do about ocean acidification. So it's thanks to them that we have this data. The work was done in both the United States and the United Kingdom, so you're going to see data from both countries today displayed side by side. And I think everybody will be interested in how closely the opinions of people in the two countries track. There's really many more similarities than differences. The research that we did consisted of focus groups first, which we conducted in Miami, Florida, and Portland, Maine, locations that were chosen just because of potential more recognizable impacts from ocean acidification, as well as in London in the UK. And those groups really helped inform our survey design. Then we did, in January of this year, public opinion polling in both countries. The samples were quite large, very robust. These are samples of all adults in the population, controlled for geographic and demographic representation. So we didn't survey environmentalists or people with a particular point of view. We surveyed a representative sample. It's helpful to know, before we even talk about a specific ocean problem, what people think of the health of the ocean in general. And at this point, in both the US and the UK, the general health of the ocean is not perceived to be good. Most people rate it as only fair or poor, as opposed to being in good or excellent health. And in addition, they're slightly more concerned about the health of their coastal waters or coastal seas than they are about the world's oceans overall. And when we think about that, it kind of makes sense, right? You think about what's visible to you. The global ocean seems like a pretty big place with, a lot of it empty to people, whereas your coastal ocean is very visible to you, what might be going on there. In our focus group discussions, it's important to remember for anybody communicating about ocean acidification, you are coming in with an issue that's way under the radar screen. When we talk to people about their, just off the top of their heads, what they're worried about in the ocean, these are the three things that come to mind. In every single group of people across both countries, oil spills and general dumping of pollutants and other chemicals into the ocean was absolutely first and foremost perceived as the top ocean threat. We did the focus groups in September of last year, so we were certainly still in the midst of the Deepwater Horizon crisis. But I have to say, I've never heard this not be the case, even when we weren't having an active disaster going on. Garbage and plastics, trash and debris in the ocean, that's also something that's very captivating. These garbage gyres that people have heard about, people talk about those in every group. And overfishing came up as an issue of concern in every group of people that we talked to. And you'll see this all borne out in polling data. So we gave people a list of various threats to ocean health. We asked them to evaluate for us. Do you think this is one of the most serious things, very serious, sort of, not too, not at all? They had the opportunity to express their level of concern about every single one of these, and what you're looking at here are the numbers for people who say this is one of the most or a very serious threat. So not surprisingly, you get all that pollution stuff up at the top of this chart, with people in both countries perceiving that sewage, plastic and trash, offshore oil and gas drilling and spills that are related to that, and agricultural runoff, all the stuff basically that we're dumping in is the stuff they're the most worried about. Then we have kind of a second tier of concerns, like loss of marine mammals, destruction of coral reefs, overfishing, loss of coastal habitat. Those kind of make a second tier. What's interesting for our issue on ocean acidification is where that comes in and relative to global warming. So if you think about the oceans, as many people have said, as the front lines of climate change, well, look at where global warming sits in public perception as a threat to the health of the ocean. Not very high, not a great And we look at where ocean acidification is, and we know that relatively few people are even aware of this issue. Like there's Yale polling that showed 25% of people had ever even heard of this. We know that people are responding basically to what it's called. Ocean acidification sounds like a bad thing, right? So about half of people are saying, well, that sounds like a serious threat, okay? If you're a communicator, though, that's encouraging because it tells you that right off the bat you have something that people can kind of start to wrap their heads around, right, and think about. The warning sign is, look at where global warming is today. We got to really think about communicating about ocean acidification differently. So we didn't do a very good job of convincing people that global warming was a problem for the ocean. When we think about how we do that, we need to think about what we're talking about with ocean acidification. So we took a deep dive on a variety of pollutants that can affect the ocean's health. And these are just the ones that sort of come from the air, as it were. And we wanted to see if people would perceive some of those differently. Well, look at the difference in what it sounds like to talk about carbon dioxide going into the ocean versus emissions from factories, energy plants, and cars. That is an enormous difference in perception of seriousness of threat, and it's poor. Every time I've interviewed a scientist, talked to them about ocean acidification, they just start talking about CO2. That's not where the public is. CO2 doesn't necessarily sound like a bad thing for the ocean. They need to understand what you're talking about and why it matters, and emissions is part of the way we get there. In terms of understanding ocean acidification, we knew from talking to people in the focus groups that most people are not very aware of the different roles that the ocean plays in the Earth system. The one that's most obvious to them is climate. It's the driver of climate. We've heard that over and over again. They also have a vague idea that the ocean is responsible for life on Earth. They're not entirely sure why, other than water, right? They don't know that much about a living ocean and what a living ocean provides in terms of the Earth's capacity to be what it is. So when we did the ocean acidification description in our survey, what we wanted to do was not explain any of the implications of this problem. We just wanted to say, this is what it is, okay? The ocean does these things, including absorbing carbon dioxide from the atmosphere, but it does a lot of other things also. Today we have more carbon dioxide out there because we're burning fuels that release them. And the ocean is going to keep on absorbing carbon dioxide. As a consequence, the water's changing and it's getting more acidic. So that's all they were told in the definition. We wanted to see what people would do with that. So right after they read that, they answered some questions, what stood out, how they felt about it. And we did get the range of responses. A lot of people immediately worry about the health of marine organisms. So that's a good thing. We start thinking there's implications for marine life. Some people start to think about the air we breathe. If they're thinking about so much CO2 going into the atmosphere that it's changing the water, they start to wonder about what does that mean in general for the air. Other people worry about fish, eating fish that's, developing in more acidic waters. They make kind of wacky connections with that. Still other people sort of say this isn't an issue to worry about. You can take a look at some of the responses we have down at the bottom. It's really not, I don't worry about it, God will take care of it. We have other people who said this is a plot, by elitists to tax carbon. So we have the range of responses for sure, just to prove to you that we've got the whole country sample. We also asked, right after they read the definition of acidification, how believable is this to you? How concerned are you about it? Do you think there's consequences to this problem? And if you do, when? Today? In your lifetime? For future generations? Maybe never? And this is what you see. A lot of people find the problem believable. They think it's being caused by human activity. It's sort of worrisome, right? There might be some consequences to it. But there's not a lot of intensity around this issue right now. So it sounds bad, but it's not something that people can just hear about and immediately get motivated to do something about, right? So these are things that we would hope to change over time as we develop our understanding of ocean acidification and communicate to people what it is we need to do. Well, just explaining it gives a huge boost to that, right? So when we had it in that laundry list of things that can affect ocean health, around 50% thought ocean acidification sounded very serious. Just explaining what it is takes that 50% up to 75%. So that's a big boost in terms of people's ability to understand immediately that this is a problem for the ocean's health. Interestingly, you also get about 2/3 of people in each country who perceive it as a potential problem for the air we breathe. That said, as a priority, it's not very high right now. It's not the lowest priority from people's perspective, but it's not one that is seen as urgent for either the government of the US or for the government of the UK to address at this point. So we have only about 1/4 of people who say it's a very high priority for the government to do something about. What we also learned in talking to people and in our survey is that how you talk about ocean acidification matters, and the narrative matters. We presented 2 different stories. We divided the sample into pieces, where each side just read a story, not both, and then we asked them some questions afterwards. On one side, you see something that looks like a scientific journal, and that's pretty much what it was. We just stole sections from various reports that had been done. I think that graphic even looks sort of similar to the one that we were showing up here before. And it just presents the facts of ocean acidification. What is it? What does it mean? What does it imply for the ability of shell-building organisms that are at the base of the food chain to build their shells? What does it mean in terms of the rate of acidification, how rapidly it's occurring, etc. I had some nice pictures of dissolving shells. And then called for a solution of immediate reductions in carbon dioxide emissions. The other half read a different story that talked about a group of coastal oystermen who were noticing that the shells of their oysters were flaky and weakened. They go to their State Department of Natural Resources and they find out that, lo and behold, the water pH has changed so much over the past time, and now they're kind of seeing that in their food. And they're sort of figuring out what's going on with acidification locally. At the same time, the government decides to open up new offshore oil leases for drilling. So these guys get together in our fake news story and say, we don't want this. They try to zone their coastal area to exclude that activity and to mandate any energy development has to be renewable, right? So the solution's totally different in this story. It indirectly talks about carbon emissions, but gets there in a totally different way. Well, people had very different responses to these 2 stories. And you see them in the changes of their perception for consequences to this problem. So after each story was read, people were asked, how believable is this problem? How worried are you about it? And does it have consequences for today? Just reading the facts does a little bit to boost believability, a little bit to boost the sense that there's consequences. Reading the story in a way that humanized and localized the issue went gangbusters towards people understanding this is an issue that actually has consequences for right now. We also want to be mindful as communicators that we have to present the facts of an issue, but we also have to tap into people's values for the ocean. And I'm presenting these pieces side by side just so you can see how the facts of the science behind ocean acidification are equally powerful to values arguments and vice versa. So different people have a different perspective. Scientists like to stay on the left-hand side of the chart. Some of us on the advocacy side or communication side, we like to always stay on the right-hand side of the chart. It's a combination of the 2 that makes a difference for anybody who's communicating. So the top things we can say about ocean acidification that really generate concern are certainly the implications for the food web, the speed of change, which was very critical in our focus group discussions. A lot of people raised the idea that the ocean is resilient. Creatures will adapt to changes in ocean acidity levels, and really the only effective counter to that perception was the rate of change being so rapid. And then coral reefs also have certainly some traction what's happening with reefs because people are aware that they're in trouble in general. On the value side, we found that relating the ocean to some of those essential functions through human health analogies works really, really well. People can understand the ocean as one of two lungs of the planet, producing oxygen, and when we're putting so much stuff into it, we're compromising that lung. We didn't use the term pH because people don't understand it very well, but people did respond to the idea that the acidity level of the ocean is like a vital sign. It's like getting an EKG and saying that your heart maybe needs some attention. They were able to make a lot of those human health analogies. Likewise, they responded pretty well to an argument about we're conducting the world's largest chemistry experiment, and maybe we don't want the consequences of that. On the solution side, people support a variety of solutions that I think dovetail really nicely to what Melissa was talking about and the monitoring and further research that Dwight was calling for. While people do support requiring CO2 emissions reductions, and we've seen this consistently, despite the fluctuations around climate change, people don't necessarily think that continuing the way we're going is the right way to go. It's just the devils are in the details about how to get there. It's the specific energy policies and specific costs to those where you start to see the support go down. But as a principle, people in both countries agree with the idea of reducing CO2. That said, there's other things that they'd like to see happen also that can address ocean acidification, like establishing sites to monitor these changes so we can understand what's going to happen in a more acidic ocean. That makes sense to people, and it's more powerful to talk about it that way than to talk more generally, look towards the bottom, about investing more money in research where they don't know where it's going. The core question is, what does this mean to me? Having local monitoring sites can bring that home to coastal communities. Likewise, protecting critical areas for stressors we already know about made sense to people when the environment around those areas is changing. And so does comprehensive planning. Last but not least, for anybody who's a scientist in the room, it's good news. People do want to hear what you have to say. We do have a lot of trust and faith that scientists will tell the truth and be accurate about ocean acidification. They're also interested, obviously, in NOAA. Makes sense that the National Oceanic and Atmospheric Administration would know something about the ocean. And interested in sort of a range of scientists, and also receptive to some degree to hearing from some of the actors that have a stake, an economic stake in the ocean. So receptive to hearing from commercial fishermen, receptive to hearing from people from aquaculture. The only people who really don't have much of a platform around here are, oil companies and tourism companies and the coal guys and all of that. They're not so interested in hearing from those folks. And there are some differences between the two countries. You can kind of see that Americans are a little less interested in any sort of international body. But, on the UK side, they're a little less receptive to some of these economic actors, including fishermen. All right, that's it for me.
There's a lot of money at stake. None of these numbers should be taken as gospel, but I think something to bear in mind is that fish economics is stupid business, and there's a lot of money involved. Around $100 billion in world trade at the wholesale level. In the U.S. alone, retail is somewhere around $70 billion. There are some of the hot spots that you heard about earlier. Many estuaries are hot spots. Come on, here we are. Come on, there we are. many estuaries are hotspots. Cold, high latitude waters. The colder waters concentrate more gas. You get a lot of it. Upwelling zones, as you heard about. Hypoxic zones. The same things that destroy oxygen are often closely related to things that lead to this problem. Oyster folks on the West Coast have been right in that coastal upwelling hotspot and had a lot of learning going on. I think we're very lucky that they were the ones who met this problem first and knew it, because the learning involved is useful to the rest of us. This is one of the people who works for not too many parts of the seafood industry have scientists working in them, but if you want to run an oyster hatchery, you need some people who know something. He is actually a French scientist who runs a lot of the hatchery operation at a major hatchery in Washington State. And what you see in the picture, I'll show it to you again later here, is what happens to very young larvae of shellfish when they're vulnerable to this problem. This particular one is an ocean quahog, a hard shell clam. And at 7.5, it dissolves and dies within days. These guys on the West Coast had very severe loss of their production, particularly at the larval phase, early larval phase. And were quite alarmed, and they thought maybe they had a disease, which they're used to having. The shellfish culture is largely about trying to figure out how to grow the things you feed them and how to keep them from dying from disease, so people are used to this. They thought Vibrio chileashi, maybe that's the problem. It wasn't. It turned out Vibrio does show up more often. It shows up as sort of the janitor. Things are already dead when it comes. That's not always the case, but that's the dominant model that seems to be happening. So here, you have the upwelling story. We heard a little about this. This is the very deep, highly saturated, CO2 saturated water coming up onto the shelf. It induces some pretty low pH conditions along the West Coast. Two of the major hatcheries that provide most of the seed for shellfish farms along the West Coast are really taking it hard. And what they've done to deal with this, it involves using two really important tools. And it's almost impossible to say how important this is. You've got to have some way of seeing what's coming at you, or when it hits you, you don't know. Much of the world's seafood production is happening in places that nobody's looking at. We have already endured very serious losses that have, whether they're connected to this has not been documented. And then you start looking at what's coming up in laboratory work, showing, for example, a 50% decline in larval survival in hard-shell clams at today's CO2 concentrations compared to pre-industrial. 50%. This is, you'd expect to see a lot of help in a lot of places for those kind of numbers. And nobody's looking for those places. These guys figured out that if you look, you can duck some of the loads. You don't get to duck them all. And you don't get to duck them forever. Because the ducking, I'll show you how it works in a minute. The other thing you've got to have is a well-defended position. What that amounts to is a hatchery. Many of us have had many misgivings about hatcheries for all kinds of reasons. But if we actually think we want seafood in a future that's going to have very high CO2 levels, there will not be a lot of options. So monitoring, the first thing you do is you get some sensors in the water, you start looking at PCO2, pH in particular, those two are the really key variables. Of course, temperature, salinity, depth, all that people do. This is a readout in the Taylor hatchery in Washington State. What we did here that caused this huge change was they have two intakes. One of them's at 100 feet deep, and another one's at 30 feet deep. We switched the intake, feeding into the analyzer. And at 100 feet deep, you had a huge change. And the pH there is about 7.5. And mind you, that water is essentially lethal to young shellfish. They don't make it that way. So they've stopped using their deep water intake. They created it a few years ago because it saved them from another problem. They had biohazards, algal blooms and things in the surface waters. So they thought, let's avoid those. Sometimes they bring disease, and we'll be better off. Well, now, what they thought was going to make them better off has turned out to be water that's dangerous to their young. What you do to survive is you duck. You spawn when the pH is high, and you don't when it's low, because then your larvae just die. And this is runs the monitoring program for the oyster growers on the West Coast. A very stolid, straightforward, simple-spoken guy who did not start out thinking CO2 was the problem, who didn't want to believe it when he found that, who thought this whole kind of global warming stuff was something that maybe he wouldn't have to deal with. You know, let do-gooders deal with that. I got a job to do. And now Alan is saying things which we'll get to shortly. Pretty strong things. And he's saying them because he's seeing it. He's not doing this because he's out to make the world greener and cleaner. He's trying to save his business. So this is a very quick look at how monitoring turned out to pay off for these guys for now. I can't tell you this is a permanent solution. It's not. As the oceans get more acidic, this solution will simply cease to work. However, it costs somewhere in the neighborhood of $500,000 to launch the system that's keeping these guys in business right now. Their total revenues are around $83 million. They lost about 22% of that over the last few years as their seed stock collapsed. They had a much greater loss of seed stock than they did of adult production because they had some standing stock of adults that are more resilient to this change in chemistry, and they can continue to harvest it for a few years. You get down here, if you figure out the economic return on that $500,000 investment, all the activity that results from getting back a lot of the production you lost, which is what they've done, it's around $35 million. So not too many propositions give you $35 million for a $500,000 investment. It's kind of okay economics. The second thing that people are doing, if the first is monitor so you can dodge, the second thing you're doing is trying to increase the adaptive capacity of the stuff they're raising and the ways they raise it. And there are many ways to do this. One of the simplest ones is to put shell back in the water so that it can buffer the water. There's a lot of people working on this in various ways. One program that does this is one called oysterrecovery.org in Chesapeake, which isn't even about ocean acidification. It just happens that shell makes a nice place for more shell to grow. One of the reasons that's true is just because the chemistry is advantageous. Now, there are other things they can do. They might eventually be able to create their own seawater that's safe from the problem. They aerate, they filtrate. They try to breed for resistance. We don't know how well these things are going to work yet. There's optimism, but no proof yet. And then you can engage in policies. And what we're seeing both among the oyster people and among people fishing is a growing interest in doing that. Quite a number have gone to bat for a lot of policies, including monitoring science and better CO2 policies. These are some of the things people in the industry are beginning to say. These are chosen in part because many of these people are Republicans and skeptics about climate change. This is actually a friend of mine at a seafood company in Seattle who started out, when I told him about this, trying to poke holes in everything I'm saying, associating with Al Gore and the Tooth Fairy, and then read the science papers and came back and took me to lunch and said this. This is a 9-term Republican legislator, former fisherman, former fish czar for the state appointed by the governor. This is a guy who's really been hard into it. And he's big because he's an old guy who wants his grandchildren to have the same beautiful life full of good stuff that he had. This is Mark Weigart, who owns Whiskey Creek Hatchery in Oregon. Again, not a guy who started out to save the world. He started out to save his business. And this turned out to be something that he had to take on. This is not something they're making up, and they're being accused by some of the denialists out there of making it up. It's kind of interesting. These are hard people to accuse of making stuff up. That's not going to be an easy case to make. Lower ocean pH, shells dissolve faster. Bill Dewey at Taylor Shellfish, which is the largest I do speak English, I swear. The largest U.S. shellfish farming company. They have about 12,000 acres in cultivation, something like that. They are starting to view this as a critical policy challenge, and they're being used on it. Dean Blanchard, who some of you may know, he's been prominent in the era of the spill in the Gulf. a character on the waterfront in Louisiana. He's also one of the largest shrimp buyers on the Gulf Coast, and his way of saying it in classic dockside poetry, which, by the way, is not necessarily friendly to environmental folks at all times, but on this particular issue, Dean has, come and spoken about this on the Hill and made his points rather well. These other guys as well are really strong spokesmen for the issue. These are fishermen in Alaska who 100 boats went out in the water. This is shot through thick cloud coverage, just clear enough to allow being able to take some of the pictures. It was low, heavy cloud coverage. We were very lucky to get it together. It was essentially an invisible demonstration until the clouds broke. And barely did, as you can see. So about 100 boats, 500 people from the town participated. This is that shot of the dissolving clams, which I'll leave you with a quote from Alan Barton, who runs the monitoring program for West Coast growers. 2050 is here now. And what he means by that is that much of the biogeochemical people will be talking about this in terms of projections that, someday in the future, a few decades from now, the ocean will become undersaturated for aragonite, and if you're not bored silly by now, then you certainly don't care, because that's 5 decades out, 4 decades out, and what, so what? It might happen first in places that are far away, like the North Pole. So what do I care? Well, Alan Barton lives where this is happening now. This is what he's trying to do, is grow these guys. And his job at this stage in life is to get a whole lot bigger really fast. And instead, the water is so bad that it's doing this. That's why Alan says 2050. Thanks.
These were great talks. We're running a little behind. We started behind, but I'm going to welcome your questions now and skip my own. So,
Lisa, I was wondering if your research indicated which particular media might be most appropriate. So, for example, whether it's films or conductors or written materials.
For the average, American who's going to pay attention to all these issues, there are 2 good ways to get their attention. One thing we found out in talking to people, they get most of their information about what's happening in the natural world from specialty television programming on channels like Discovery, Animal Planet, National Geographic. So those channels now have a broad reach, with a lot of people occasional viewers of them. The other thing we found is that people are more likely to hear about a local story through local news channels than they are to read a local newspaper. So like you see numbers for newspaper readership still seem fairly high, but the reality is that's so sporadic. TV viewing at the local level is much more uniform in that sense. So.
And for Melissa, you spoke about hotspots. So we have one of those off the coast of the Pacific Northwest. What are some of the others that you have found globally?
So we're chosen by the Gulf of Maine, the Kennebec River Group there, with lower pH, in Chesapeake Bay, there's some evidence, in areas of New South Wales. And a lot of these are correspond to river communities as well as that have sort of higher levels of nutrients and pollutants that are entering into the soil.
Have you expanded that to an international level?
Yeah, so there's also a recent paper on Japan showing some evidence there of the same as well.
Yeah, I actually had 2 questions. For Lisa, I was wondering if you are seeing similar results about climate skeptics being more open to ocean acidification than they are to climate change.
I think it depends on how you define a climate skeptic. You're talking about the type of people, the very small group of people that blog and are actively, I think, attacking or denying climate science. This is just another thing that they're going to attack and it's on their radar screen. If you look at people who are, I don't want to say dismissive, but people, there's been research sort of classify American attitudes on climate change, and they sort of put people in 6 different buckets that range from alarm to dismissive. If you're dismissive about climate change, you're dismissive about a whole host of environmental problems. But if you're in the camp that's sort of doubtful or thinks that the science is unclear, on this particular issue, it does have more traction, mainly because people can understand ocean acidification as an ocean problem. So you're not asking them to project out to some apocalyptic future necessarily, but if you say, does this sound like a bad thing for the ocean? Yes, it does. More so than climate change does to them.
That makes sense. And my other question was actually for Melissa. You mentioned that atmospheric CO2 was only a part of the story. I'm trying to get a sense of how much of a part of the story is it. How much, and you mentioned the Kennebec River, the rivers being a big impact. How much of it is atmospheric CO2 and how much of it is local impact?
Right. So in these estuarine areas where central serve is starting to just get a handle on these additional mechanisms, there's estimates of anywhere between 10 to 50% of the contribution of decreasing years levels. So
It's from the other things, not
just
here.
from these local drivers in addition to CO2. So a fairly substantial amount.
Great, thanks.
I'm just thinking about lessons from the last 20 years of climate science, and the fact that, much of this research has been in the last 5 years. Most of my questions are to Ned. Just quickly, how extensive are there biological indicators of ocean acidity? The Foley study in 2008 back to 1775. So I'm just wondering if you find, in climate change, the Vostok ice core, fossil record, all kinds of things that show what carbon dioxide levels. Second question, I'm going to do the 5 quickly. Second is vulnerability.
Wait, just so I understand, so the first question is really talking about our understandings of changes in ocean chemistry or geologic time,
Yeah.
and how responses to
How far back can you see ocean acidification? Can you go back 1,000 years, a million years?
Yeah.
How extensive are the markers? Because a lot of the climate science stuff has been filling in all those gaps.
Sure.
And this is all like since 2003. Ocean acidification and research, and we need a lot of research done 15 years ago. So how much of it is already out there and this needs to be measured and then associated with telemetric monitoring that's now?
Yeah, right. So I just take them one at a time. Go ahead.
I don't have time for 5 questions, unfortunately, but.
Oh, so is that your best one, or?
No, actually it's not.
Me too, just because there are a lot of questions in Jared's and golf's.
Okay. Second one is vulnerability of species. Is that kind of due to the size? Is there any part of the vulnerability of ocean acidification? And how is ocean acidification poised to alter the ocean's ability as a carbon sink through time?
Yes. Okay.
Okay.
I'll take the last one first.
Okay.
The actual sink of the ocean will be declining over time. Okay. So the models that we showed, which showed that the decline in saturation state and saturation to higher latitudes, that includes the fact that they will be in fact declining, being less capable of absorbing CO2 over time. And we've seen that already. So from an ocean acidification perspective, that's great, but it means that's not great, but it's a bonus. The downside is that the carbon has to go somewhere, and you're fishing amongst your reservoirs, so that means that there's no way to do anything here. I'll take the first one. In terms of the geologic timescales, in terms of saturation states, as we look back, it's difficult to put precise numbers on it, but our best geochemical evidence seems to suggest there have in fact been periods, absolutely, where acidification events have happened at the Permian event, at a rapid decline in saturation states. We did see rapid ocean acidification, and there was a major ocean extinction event as a consequence of what the rate of that extinction event is not entirely clear, whether it was 1,000 years or a million years. We're still uncertain on that, but clearly there was a significant effect on the oceans over time. I think what puts us in a precarious place relative to the rest of the geological history right now is that over the past several million years, of no fault of us, calcium concentrations have been on the decline. Okay? So if you look at the carbonate ion, which we are now rapidly perturbing, we're doing it at the same time that, just for geological reasons, calcium's been declining. What was the second one? Was the size of the organisms regarding the sensitivity to acidification? I don't believe there's any definitive indications that any research that specifically looked at the size of them. No.
Yeah, so if you think about organisms that have a faster turnover time, they may have a larger capacity to adapt to changing pH levels faster than organisms with a longer lifespan.
For Brad and for Melissa, do the adaptation strategies for aquaculture industries differ in regions that are subject to acidification caused by these multiple stressors as opposed to predictable upwelling that you know 24 hours in advance that you're going to get them, but without in the purposes of further dial cycling and undetermined temporal impacts for the industry? So how would the adaptation strategies work? Would they be similar or different in the West Coast or East Coast?
Well, right now they're very similar. We just essentially replicated the monitoring system used on the West Coast to Maine, and people there are now doing the same thing, logging your data and starting to look at it. They don't know whether they have a problem or not, but they sure want to find out. And they didn't have adequate monitoring even to know. At this point, the only place that there's a track record to evaluate what works is the West Coast, because they're the only place that's got the monitoring as far as we know. Having said that, they say that their peers in the industry around the world, particularly growing oysters, are experiencing a suite of complications that seem to have a kind of, the way they read it, something's going on everywhere. I think we can expect to see, in fact, we are working to make sure we see monitoring implemented in a lot of those other places so that people have the chance to figure out what kind of adaptation works. And frankly, to call it adaptation, I think, is a bit of a cruel joke. I think this is a defense strategy. You got to pay the Defense Department. You don't pay an adaptation department. You pay, it's very, very costly. And what happens to your earnings as a business out of this could be extreme. I mean, it's not costly right now to do the monitoring and then time your production. You can do that pretty cheap. But if you have to start getting into breeding animals that are resistant to this and making your own water, you can really quickly get into just a cost sink. I think right now, because those diurnal variations give you some room to move, and the low part of the pH passes through the boundary between tolerable and intolerable conditions on a regular basis still. It will cease to do so because things will just get too much. Yes?
For Brad and for Dwight.
Actually, you asked that of Melissa as well.
Well, the other part of the question was just in
I'm
the
sorry, we'll
system
come back.
that you're seeing the temporal, or you're seeing the multiple stressors, not more so than a single predictable upwelling signal. Does that present an additional challenge, and how does the industry?
We don't know the answer yet in terms of what the industry's seeing. The data isn't there to show. There's anecdotal evidence, I think, is pretty convincing that there is some other stressors, that there are other stressors at play. And there are people who, frankly, are willing to deal with those who are not willing to deal with CO2. It's ideologically acceptable. And frankly, useful for them to do it. So we encourage it. Why not?
I think a lot of the land-based stressors, including river input, generally tend to occur after storm events. And so there is some predictability of at least that. And whether if it's a hatchery, you can sort of kind of mitigate those effects sort of in the same way that in upwelling by just not spawning at those times. But for wild populations, in the Gulf of Maine, that's the example where you have these river plume events that are generally occurring when these clams are spawning. The wild population, there's not much there.
We were in the middle of a question.
For Dwight and for Brad. Dwight, did you see the Nature article March 9th, 2011. Frank Melsner, Leibniz Institute, said you don't see as much trouble. Actually, it was a study of two kinds of blue mussels. Some in acidic waters, not enough nutrition, they drank. But others in the Baltic, same blue mussels, did beautifully because there was a lot more nutrition compared to the Tyrrhenian Sea where they have volcanic vents that is a nutrition deficient area, and it spews CO2, so of course we've got nothing there. And the question for Brad is, we've been to Taylor, we know Bill Dewey. Do I remember correctly that they get their spawn, their spat, from the Big Island of Hawaii, where they get 3,000-foot upwelling from OTEC from Nelha? It's either Kauai or
They have a facility in Hawaii.
yeah, I think it's.
I don't know where it is.
I think it's the Nelha facility, which is 3,000 foot. So all deep water is not created equal. If you go where it's very salty or very acidic, that's what you're going to get.
Right. That's not where they get it all. That's only one of three facilities. Yeah.
I was looking very carefully at the other consequences of that. And so if you look at the eastern tropical Pacific where we have these reef systems, which we looked at now, these reef systems are eroded out entirely because, one, the high magnesium carbonate phases, okay, which are actually more soluble than aragonite, they tend not to persist. They're gone because thermodynamically they will dissolve. And those reef systems have much less cement abundance, part of those reef systems. And by virtue of the enhanced nutrients, which, you're right, in many organisms, so we have indications in Cohen's work that some corals can actually maintain their calcification rates by if she manually feeds them, okay? Which is good for the coral. And in fact, in the eastern tropical Pacific, some of the corals actually are doing quite good, but they exist within an ecosystem which is largely eroded out. And the enhancement to the biologotors of that ecosystem negates any benefit you might gain from, the fact that you may have preserved calcification by using the nutrients. So you can look at a specific species, you can compensate for it, perhaps by feeding it with nutrients. But you also have to consider the fact that if you're inducing nutrients to that environment, that's a whole ecosystem effect. And so you have to consider all the effects and not just look at that one coral. But you're right, the specific species, specific effects can be unique.
This is a question for Melissa. You mentioned the Clean Water Act as a potential solution, and I wanted to know if you knew of specific pH TMDLs in various states, and are there any state policies that are oriented specifically towards pH? That's a sort of a solution you didn't mention, that it can be implemented for various permitting schemes. So
to my knowledge, there are no TMDLs set for pH, but the range for pH in the Clean Water Act is set at a change of 0.2 pH units outside of the normal range of variability. So that's sort of the range at which states are required to list water.
But you're saying that 0.1 pH induces changes in the environment, right?
Right. So for example, in Puget Sound, pH varies dramatically. Graph showed this over time, and so they don't want to just say a blanket 0.2 change in pH because natural processes fluctuate that much in some systems. So it's just outside of the normal range of variability.
So we have to wait for it to get twice as bad? I'm just trying to understand before you invoke the ability of the Clean Water Act to regulate it.
Yes.
Okay, are there any state policies that are existing that address pH outside of just the Clean Water Act?
So with the Coastal Zone Improvement Act, correct me if I'm
Well,
wrong.
other than those.
Yeah. Otherwise,
No,
not that I can think of.
I'll just try to help out a little bit. Melissa is a PhD scientist, and the settlement agreement between the Center for Biological Diversity and US EPA really just asked EPA to start to chart a course whereby the Clean Water Act would be put into action to address ocean acidification. And so, the first step was US EPA asking for a lot of information from folks about whether it was appropriate to do this, and if so, how would we do it? And what they got back was, the scary side of this is that there's so little monitoring for it and so little understanding receiving waters that are so important economically that the nation wasn't poised to set a national standard yet. But they have encouraged individual states, to aggressively pursue monitoring along the lines that's been suggested here by both NOAA and by the fishermen, to really start to get a handle on what natural variability really is, be in a position to set MPLs if necessary, or pursue other avenues through the Clean Water Act. I mean, I think part of it too is adjusting the mindset that Clean Water Act, Clean Air Act, local coastal programs, other programs, you can start to look at RCRA and CERCLA and FIFRA differently, to look at all of these laws differently with ocean acidification in mind. And so with the Clean Air Act, for example, making an endangerment finding based on localized hotspots.
Okay, so with that, do you guys have a preferred course you would like to see? EPA chart or a methodology with existing statutory ability that you would recommend that those of us who deal with that rather than the science of what's happening sort of focus on in our advocacy?
Can I just say that this has come up several times in discussions that we've had, and at least from the geochemist perspective, we wish very much that we could be moving away from talking about monitoring pH. pH is what people always think of, but it's probably the worst parameter to measure.
Okay.
It's just, it has a lot of baggage with it, and within what we call a mesohaline environment, like within an estuary, we know pH very well in freshwater, and we know pH very well in seawater, and that when they meet, all hell breaks loose. And the chemistry of it is very difficult to interpret. And so measuring pH, which we do now because oftentimes we have to, it's just, I'm seeing, especially the EPA, marching in this direction of what are we doing about pH? And I'm saying this isn't a pH. Much of my talk, I didn't talk about pH. It started there, but it isn't pH. And the ultimate concerns that we have is maybe the changes in saturation state, which is a much more nuanced, convoluted term. And so when I say if you want to invest resources or invest legal efforts towards monitoring something, I would say let's talk more about what you should be monitoring. And pH wouldn't necessarily be where I would go.
That's helpful to know.
Yeah, Dwight, that's a really good
That's
clarification.
very helpful.
Because, I mean, there are historical data sets that the EPA has of pH, and they say, oh, well, every couple of months we went out and we sent somebody with a bucket, and they stuck a pH probe in there. We got values. And they come to me and they say, what use can I make of that? And I say, fill a trash can with it. It's not very useful.
Well, that's not exactly the answer I was hoping for, but it's an information about what is not the answer. So.
Yeah, I would encourage them to have more conversations with nerdy geochemists or carbonate chemists about what they should be monitoring. And there are a lot of folks working with new technologies to monitor some other things. And even Brad showed that we don't measure pH even within those systems. We measure pH coupled with particle pressure of CO2. And we do the pH that we have to measure. The only thing we do autonomously. But there are other things that we want to measure to really monitor the system. And we're getting very close to that.
And even the not very nerdy oyster guys will tell you that PCO2 is more useful than pH as a management metric. When you're trying to manage a resource and not kill your animals, you want to know PCO2.
Can I pile on with a 30-second anecdote? We have ponds in Texas, 45 acres. We had an incident last summer where we had a foot of rainfall in 24 hours. The main fish farm, a half hour away from us, only got an inch, no problem. But our most productive pond killed everything. The good news was all of the calcified fouling organisms on any of the cages fell off because it got so acidic so fast. If the Iowa folks are correct, that they're getting more intense rainfall, stronger storms, which is washing away more of their shore, one wonders if that's part of what we're seeing, which is this bam, just this deluge, and pH numbers, they skyrocket, and then they come back down. But if you happen to catch them at the moment when they skyrocketed, yes, they had an impact, but it was transient. But it's also long-term, so how do you measure that?
I would hope that gentlemen like you who are sort of looking at the science of it in a nuanced way could be very involved with the EPA sort of standard setting. And especially in states like California, where they're inclined to be a little bit more aggressive about setting TMDLs, it would really benefit the discussion to have NOAA and gentlemen such as yourselves participate heavily, because people like me have not been hearing information like this. I've been assuming it's pH that we want to understand.
Well, there's a reevaluation of the pH standard by EPA right now, and they got a lot of information from all the country chemists. We're working on this, so they're in the process of trying to address these questions. This has been a great conversation. I want to thank the panelists. Thank you so much, everybody. You can ask some questions maybe later.
This is to me.